any reply or anything, because data transmission will move only in one direction. So that's why here there is no chance for errors, because we don't prefer for, that means there is no chance of getting some reply back from the users. Now, what is this Simplex Stop-And-Wait protocol? Also, we try to transmit our data in one direction only. But when you are sending your data without knowing about the receiver situation, sometimes we may be affecting with a problem of flooding. So what is this problem of flooding at receiver side? If sender is sending more number of data frames, but receiver is unable to accept all the frames, so at that time, number of frames are going to be stagnated, which is needed for flooding at receiver side. So how to overcome this problem? Means this problem can be overcome by sending a feedback to the sender. So not only this, the receiver can send an acknowledgement frame so that the sender is going to know that how many frames have been received by the receiver. Otherwise, the sender don't know whether that frame have been received to receiver or not. So if we are sending back an acknowledgement, then the person come to know that so and so frame have been received. For example, you have sent some 5 frames, but you got only one acknowledgement back. That means remaining 4 frames have not yet received by receiver. That is the feedback to the sender. So by this method, we come to know that whether the frame what we have sent is received by receiver or not. So this is a general solution. So for this purpose, we are going to have this next protocol called as stop and wait protocol. So according to this protocol, what is happening here? Sender is sending a frame, but again second frame is not transmitted. It waits for some time. First it sends a frame, stop sending, wait for acknowledgement coming from receiver to the sender. Once acknowledgement is reached to sender, now sender again sends the next frame. So this is a mechanism of stop and wait for acknowledgement. That means first it sends one frame, it stops the process and wait for acknowledgement. So this protocol have been named as stop and wait protocol. Clear? The next is a simplex protocol for a noisy channel. So a class I have discussed with you about this. Sometimes because of some noise in the channel, there may be chance of happening some damage to the frames or damage to the acknowledgements. So how that is going to be achieved and how that is going to be overcome. So that is our third protocol. Here I have explained you about 2 situations. When sender is sending packet, see the number of packet here, packet 0. It is received by receiver, but receiver is not sending he is sending acknowledgement, but acknowledgement is not received by the sender. So at that time, the sender will think that packet 0 have not been received by receiver. So what sender will do? After some period of time, if acknowledgement is not returned to the sender, again the same packet is transmitted. Okay, because of this, what will happen? More number of duplicate packets becomes more. And coming for second case, packet 0 sent but not received by receiver. So no acknowledgement came from receiver. At that time, sender waits a period of time and again he will resend the same packet and again get back the acknowledgement. Okay, so this is our second case. Now, whatever the mechanism we are implementing here, it is shown clearly here. When sender sends the packet, that is frame 1. F1 stands here for frame 1. Acknowledgement is received to sender. Then again sender sends the next frame, that is frame 2. but acknowledgement is sent but not received to sender. So again we will resend the same F2. Now acknowledgement have been received. Because of the sequence numbers, the receiver come to know that this is frame 2 which is already received to the receiver. So it is going to be neglected. Is going to be neglected. Okay, so this mechanism is going to be followed in this a simplex protocol for a noisy channel. Now coming for the this particular thing, that so how you are going to overcome this problem, that is the first problem here, and second first problem is with the help of sequence numbers you are going to overcome this particular problem. So like this, we have a mechanism of sliding window, that is elementary data link protocols. This is a figure is going to show you about stop and wait protocol flow diagram here, but no need of all those things. But anyhow, you have to remember one concept, that here we are using a protocol in order to send data from sender to receiver safely. So for that we have been here designed the three different types of protocols. The first one is an unrestricted simplex protocol where there will be no restrictions but time consumption will be more. So we are shifting now to the next one, that is called as stop and wait protocol, because the receiver is unable to know, the sender is unable to know whether it is received by receiver or not. That's why we have shifted the second protocol called as stop and wait protocol. After that, we have one more protocol which have been designed for noisy channel. Because of the noise in the channel, sometimes packet may be lost, frame may be lost, or acknowledgement may be lost. At that time, how to overcome the problem that we have discussed in our protocol. Now we are moving for next set of protocols, which is called as sliding window protocols. Very, very important. Okay? That is our today's topic. So till here, if you have any doubts, you can ask me. Otherwise, I'll continue this sliding window protocols. Do you have any doubts after this? Shall I continue with next topic? Now we are discussing about sliding window protocol. See here. Now, data frame transmission. Unidirectional, that is assumption in previous protocols. Full duplex means that is we have two separate communication channels. One channel we will use for sending data. The another channel we will use for sending the acknowledgement. Okay. So these are the two methods what we have seen in our previous protocols, which are called as elementary data link protocols. So మీకు లాస్ట్ చెప్పిన నేను ఎలిమెంటరీ లింక్ protocols ఉన్నాయి కదా. So that protocols, whatever the assumptions we have made, this is the thing, that is unidirectional assumption in previous elementary protocols. Uni means nothing but only one direction. There is no reverse direction. And also we have discussed about full duplex. That means in our stop and wait protocol, what we have turned simplex to full duplex. Why? Because you are sending your frame and you are expecting back with acknowledgement. That means here you are going to have some two separate communication channels. One is for sending data, the other one is for getting the acknowledgement. Because of this, what will happen? There will be some wastage of bandwidth and cost is also becoming more. That's why now we are going to have these mechanisms in our present protocols. So full duplex, you know very well, full duplex means what? That is, data is going to be transmitted and you are getting back with acknowledgement in different channels. Now, same circuits for both directions, data and acknowledgement are intermixed. How do we tell acknowledgement from data? How you are going to come to this second approach? Already we have seen about the first approach where you are going to send with data with one channel and acknowledgement with another channel. But what is the problem with this approach one? Wastage of bandwidth and cost is more. So we are going to shift to our second approach. According to second approach, what is going on? What is happening is you are going to send back both frames and acknowledgement at same time. So how it is possible? That is possible with a concept called as piggybacking. The term what we are pronouncing is piggybacking or piggybacking. But piggybacking is the term what we use here. Piggybacking. So what is this piggybacking? First we'll see here. Temporary delay in the transmission of outgoing acknowledgement so that they can be hooked on to the next outgoing data frame. So, you should observe one thing. When you are sending your data from sender to receiver, again you are getting back with acknowledgement from receiver to sender. Only for acknowledgement purpose, we are wasting a frame. We are wasting the bandwidth. For that purpose, we have been introduced with this new concept called as piggybacking. What we will do is, for example, if you are sending frame 1, frame 1 is received to receiver. And suppose if receiver is again sending some data to the sender, at that time, along with that data, we are going to attach the acknowledgement of previous frame. That is called as piggybacking. That is called as piggybacking. So because of this, the bandwidth is not going to be wasted. Okay. But what is the complication present in this one? Means how long the sender has to wait for piggybacking. Why? Because we will be waiting for certain period of time. Within that time, if you are not getting back with reply, again sender will resend the same frame, right? So that is the problem here, that how much of time a sender has to wait for piggybacking. That is our present concept. Now a solution for this is, the new packet arrives quickly piggybacking. If no new packet arrives after a receiver acknowledgement timeout, then we are going to send the frame itself. Okay? Then we are going to send separate acknowledgement frame. So that is about the solution for this problem. Okay? Is it clear what I am saying about piggybacking for everyone? If you have any doubts, you can ask me. If you know this concept of piggybacking, then you can continue with the next topic. Otherwise, you are unable to understand what I am saying. So, first try to understand the concept of piggybacking. Is it clear to all? Otherwise, I'll repeat the same topic now. Very good. So, I'll explain this piggybacking once again. See, I'll tell you with the help of one diagram here. See, in the previous protocols, how you are sending your frame? You are waiting for acknowledgement. Means sender sends one frame and receiver will send another acknowledgement. Only for acknowledgement you are sending this frame. Is it wastage of frame? Is it wastage of bandwidth or not? Is it wastage of bandwidth or not? Tell me. Is it wastage of bandwidth or not? Again, you are sending only acknowledgement with this. Answer to my question, ma. Anyone please unmute yourself and answer to my question. Okay, so that means here you are sending only acknowledgement with this. That's why in the next topic what we are doing is when sender sends a frame, it is received by receiver and it waits for some time. If receiver is sending any data to the sender, at that time that particular frame is hooked with the previous frame's acknowledgement. This concept is called as piggybacking. This concept is called as piggybacking. Okay, so that is about piggybacking. అంటే మీరు ఫస్ట్ ఒక ఫ్రేమ్ సెండ్ చేస్తారు, ఆ ఫ్రేమ్ కి అక్నాలెడ్జ్మెంట్ మాత్రమే పంపిస్తే వేస్టేజ్ ఆఫ్ ఫ్రేమ్, wastage of bandwidth, cost is more. That's why what will be done? Receiver will wait for some time. If receiver is sending some data to sender, to that data frame, we are attaching our acknowledgement for previous frame. Okay, that method is called as piggybacking. So with this, we are getting with two complications. What is that means? How much of time the sender has to wait for the reply so that he will send the next frame, right? So for that, we had a solution here that just we are going to, if a new packet arrives quickly, then piggyback. Suppose no new packet has to be sent from receiver to sender, then the acknowledgement frame itself. Okay? So like that, we have designed our approach 2. That is our new protocols. That is the sliding window protocols what we will discuss today. Now, is it clear to everyone about piggybacking? Suppose you have doubt, you please ask me. No problem. Okay, piggybacking. Okay, right. Now, the next one, sliding window protocols. So actually, we have here given with 3 protocols. These 3 protocols are bidirectional protocols. That means data transmission is possible in 2 directions. Okay. Now with this, what is our first protocol? That is 1-bit sliding window protocol, go back and protocols, selective repeat protocols. So these are the 3 protocols which are called as sliding window protocols. Now these 3 are different from one another, but these 3 are going to have a mechanism of bidirectionality. Okay, now we'll see about this key concept behind this. Sliding window protocols are going to accept for full duplex. Full duplex means what? Data transmission will be at both directions. So because of this data transmission at both directions, the transfer speed will be more. Automatically the speed will be more. Now we'll see here. Here, sliding window, we are calling this as. Here, you know about the concept of windows. Just like how we have a windows in our home for some ventilation and for some air. Here we don't think about that window. Here it is different. Sender will maintain one window at sender side and receiver will maintain one window at receiver's side. Now we are discussing about sender side window here. Just observe carefully. This window is for what purpose means? In order to know how many frames are present for transmission. Okay. And sequence numbers are given here in order to know which frame you have sent for that purpose. Now sender maintains a list of sequence numbers that is allowed to the sender window. Now the size of sender window is at most. What will be the size means 2 power k minus 1. 2 power k minus 1. That means, example, if a frame allows 3 bits, then the size of window is 2 power 3 minus 1. 2 power 3 means 8. 8 minus 1, 7. 1, 2, 3, 4, 5, 6, 7. Sender's window size is 7. When you are sending with 3 bits. Now the sender is provided with buffer equal to window size. Suppose if it requires some more frame to say, at the time there will be a buffer space, there the sender will store the next frame. Okay, so that is. Now coming at receiver side. Receiver is also going to maintain with a window. Receiver always maintains a window size as 1 here. The receiver acknowledges a frame by sending acknowledgement frame that includes the sequence number of the next frame expected. So what it will do means it is going to send back the acknowledgement. At the same time, it is also going to send with the sequence number of the next frame expected. So that we'll see in the coming diagrams, you can understand. Now, what is one-bit sliding window protocol? Suppose if k is equal to 1 at sender side, then the size of sender's window is 2 power k. That means 2 power k means 2 power 1. 2 power 1 means 2. 2 minus 1, 1. This is same as stop and wait protocol. Okay. Just I have been here shown with a simple diagram. Just observe carefully here. Initial A, figure A, it is going to show you about this is initial stage. Initially, sender is getting ready to send and receive. See these two diagrams. These two are called as A and these two B. These two C. These two D. It is at sender side. It is at receiver side at the same time. So first at sender side, it is getting ready to send data. Right? When it sends data, the receiver is almost waiting to accept the frame. Okay, that is some time have been consumed. Now, go for sender side, it have sent. Okay, it is received. Now, sender is waiting for acknowledgement. Right? So, at that time, it has sent the acknowledgement to the sender. So, again, the time have been shown here. Now, the acknowledgement have been passed to sender. Now, sender is again getting ready to send with the next frame. So, these are the situations. See, first initial, after the first frame has been sent, and this is the first frame have been received. It is sent by sender and received by receiver. Once it receives, what it has to do? It has to send back an acknowledgement to the sender. After first acknowledgement has been received, this is situation of sender at sender side. Okay. Now it is getting ready to send with next frame. Okay. That. Now see this 1-bit sliding window protocol. So is it visible to all? Just make it some assuming, because you must know this. Just observe carefully. Sender A is sending, see, 0, 1, A0. What is this sequence actually? What is this sequence? This is sequence number, this is acknowledgement, this is packet number. Packet number. Same. Sequence number, packet number, both are same. But sending from A, so it is attached with A. What is this one? It may be the acknowledgement for previously received frame or previously received packet. That concept we call it as what? Piggybacking. Right? So that is the sequence of these three numbers what we are going to show. So now 0th packet is sending to B. Now B gets this. If B gets this, what will do? What the B will do? B is sending one more data packet to A. So this is 0 because it is the 0th packet sending from receiver. Now B. So 0. And what is this ma? Second field. Answer to my question. What is the second field? Acknowledgement. This is the acknowledgement of this one. A0. So 0. Now this is the 0th packet sending by B. Now it is received to send. That is A. Now again A sends the next packet. After 0, the next packet number is 1. So 1. And this is the acknowledgement of this B0. And this is the next packet. And it is received to receiver. And again, receiver is sending back with one more packet B1. And this is the acknowledgement of previous frame or previous packet. And this is the number of this present packet. Then A gets. Again, A sends with 0, 1, now 2. Similarly, same 3. Again, B sends with 0, 1, 2. Okay, so this is a situation what we call it as, it is a normal situation. And sometimes we will also affect with abnormal situation. It is shown in figure B. But first try to understand the normal situation, then we go for that B. Okay, so up to here, if you have any doubts, you can ask me, then I'll discuss the second case. Okay, so just wait, I'll take some attendance for you and I'll continue the class. Till that, if you have any doubts, you please ask me. Just wait for 5 minutes. Okay, I'll explain, no problem. It is difficult for us to explain through this online mode, but anyhow, I'll try my level best. Just wait, I'll take attendance in the Google Sheet. of any
మేడం స్క్రీన్ ట్రైన్ చేయండి మేడం.
చేశానే కనిపించట్లేదు మీకు ఒక్క నిమిషం వెయిట్ చేయండి. Right. So see here, let us assume we have two nodes A and B. For example, if A is sending data, this is 0th packet and A0 means A is sending 0th packet. And what is this one? This is the acknowledgement of any previous data packet. Let us assume, okay? Because of the concept of piggybacking, we are not sending acknowledgement separately. We are sending acknowledgement with the next outgoing packet. And చెప్పాను గుర్తుంది కదా piggybacking లో. So like that you are sending some acknowledgement. Okay? So 0 is the packet. Now B. B gets 0th packet and acknowledgement 1. So it is shown with star mark here. Now B is sending some more data to A. So this is B's first packet. So 0, B0. And what is this 0 called as? ఈ 0 ఏంటి చెప్పండి? ఇక్కడ ఉన్న 0 ఏమవుతుంది అప్పుడు? Acknowledgement of this packet. A0 పంపించాం కదా A నుంచి. ఆ A0 ప్యాకెట్ యొక్క అక్నాలెడ్జ్మెంట్ ఏంటి అంటే here we are attaching with B0. So B sends. Now A gets 0, 0, B0. So shown with star mark. Now A is sending the next packet. So after 0, what will be the next packet? 1. So 1. What is this 0 tell? So this 0 is the acknowledgement of B0. So 0. Now A1 is sending. Now B gets this. So shown with star mark. So B is getting 1 and 0th acknowledgement and A1 packet. Now B is sending B1 packet. So 1. This 1 is the acknowledgement of A1 and B1. So like that, it sends from A to B and gets from B to A, again sends gets. Okay, so this class, because I don't want to confuse you, so you please focus on this, and I'll continue in the next class same topic itself, so that you'll be getting some clarity about it. Okay, so it takes some time for you to understand, no problem. Once again I'll explain you, but for the next class you should be ready with a concept, what is piggybacking, okay, and what are elementary data link protocols. అది చదివేసి ఉండండి. మీరు చదివితే మీకు చదివితేనే మీకు అర్థమవుతాయి. నేను చెప్పింది ఒకటే కాదు, నేను చెప్పిన రోజు వెంటనే మీరు నోట్స్ తీసి చదవండి అమ్మ. Then you will be getting clarity about the topics. Okay, so just wait. Some problem in attendance. I'll try one more time. Okay, ma. Now you can leave the class. Next class will continue with same topic. You please go through that once.
మేడం హలో మేడం
రాజా
మేడం
చెప్పండి.
మేడం డోర్ క్లాస్ రూమ్లో వాడు లాజ్ అయ్యాను మేడం.
అవునా, ఒక్క నిమిషం ఇట్టే నాకు నెంబర్ చెప్పు, నేను చేసేసి